A very warm welcome to Talkspoon, the technical magazine with Wolfgang Rudolph. Hello and welcome. Today is about a theme, coating thickness measurement. Coating thickness measurement. Measuring describes itself really. You measure the thickness of some sort of coating. How you measure the thickness of something like the thickness of paper or whatever, we all know. This is when it is in small errors. You just take a caliper gauge and to measure the object, clamp in and read the results. Years ago you had to read the numbers. Nowadays you have a digital display. When it is thinner, for example, I've brought along my magnet card from my old pocket calculator, then it gets difficult when you want to read. It is a little inaccurate, but you could take a micrometer where you come into the thousandths area, and when you then measure, then you have to try to read the result here using the lines, how thick the measured object is. That is all possible when, though, for example, on a finished piece, on a metal plate which is coated, on a large circuit board or anywhere, for example, something like this, want to measure, have we here the right thickness, the copper coating, or the right thickness of the lac, then it gets difficult. I can't just go into it with the caliper, or if you maybe have seen how an expert measures a vehicle if in case it has had an accident or something and has been repainted, because then the lacquer thicker is. How do you do that is a very interesting story, and I will try to explain a little bit how it can work, how you can measure something without even taking it into your hands. Have a look at this. I've brought my bed with me for my mobile phone. It lays on a black case, and this black case, when I take this away, is a so-called QI adapter, where it is inductive loaded. For this also, my telephone has to be able to do this. On here I have a so-called coil. That is what it looks like in the telephone. Little and fine, it is a previous model. This is laid on here, and inside are electronics. They make voltage, and my battery is loaded. Because inside of this black piece is also a coil, and that is the principle of a transformer. A magnetic field is built up and demolished again, up and down all the time. A voltage is made in a receiving coil, balanced and so forth. This has no iron core. A transformer has naturally an iron core. It looks like this. Years ago this was done, nowadays it is done differently, and here you can see something very interesting. The iron core here is laminated. It consists out of thin sheets and not from a massive core. Why? Very simple. Through the magnetic field, building up of the magnetic field in the iron, an eddy current is made. And this eddy current causes losses. That is why they have cut the iron core into very thin sheets to become many small eddy currents, to have less losses as by a thick one. And this effect is not wanted by the coating thickness. We want these losses. And how do we find out if anything is in there? First of all, you have to decide between iron and not irons. Both have to be measured, and for both you use different processes. I have done a small trial. Maybe it'll work here. I have here a cooling body out of some old computer, and this cooling body has no wires, or is not a coil or so, just a piece of metal. And when I lay it onto the loading device and have a look at this small USB measuring device, and you can see in the blue area how the electricity flows. that this loading device always takes electricity to itself, even when nothing is on it. Now put it on and you can see electricity goes up to show the effect again. So that was nothing. So now the voltage breaks, so an electricity goes up, depending when I put it onto it. So power is taken even though electricity doesn't flow, because inside this cooling body eddy currents are made. And now it is totally clear, when I want to measure a coating thickness, then I go with my coil, which I have in any sensor, onto the material. Inside the coil a magnetic field is made, it is sent out, and in the material an eddy current is generated, and through the coil more electricity flows through. That is totally inaccurate. The measuring devices today are high precision. You can up to 0.1 mu coating thickness measure. What in millimeter is, we know that a meter is around that. A millimeter is a thousandth of that. You can see this on the caliper. When I show you the gap, you can see this. Approximately here you can see the gap there. That is 1 millimeter, and from this a thousandth of a mu, and from this a tenth. That is what these devices resolute. Insane technique, and uses is so child easy, I was thrilled. I have here a measuring device, the CT 65 from PCE, a small device which is easy to take with you to put in your trouser pocket, even though there is a nice case with it. We can have a look at that in a minute. And with this I can measure coating thickness. I'll just show how simple it is. It turns itself automatically round when it is so set onto the material recognition. For example, when I put it onto this and measure, then it tells me I have a coating thickness of 21.8 mu, and NFE means not iron metal. Now we go to the other probe, which is also delivered with it. Let's have a look. 17.8 and FE, that is iron metal. And while we're here, in front of us are calibrating foils. I think you can recognize them. You can use these to calibrate the device. It is capable up to 0.1 mu to resolve. That means this device can a tenth of a millionth of a meter resolve. That is totally enormous. Depending on the measuring area it goes to, 1.3 millimeter or 1.35 millimeter up. There's the resolution naturally smaller, but we know that from other devices too. So higher the end value, so smaller is the resolution. But this can do everything you need in private life, but also in working life, to determine coating thickness quick and exact. I will show you the menu, what it does. There are different modes. For one, we have here the working mode. When I go now in the menu to measure view, when I have a look at the measurements, and can change to the group 10. I have many measurements in there. Confirm it. I get measurements shown. Oh, I came to group 1, but that doesn't matter. There are also measuring values in there. That is the first measurement, not iron metal, 22.2 mu. The second one is iron, 11.6, and so forth. I can in these groups 50 measured values store, and later call them up, and can store 30 groups. For one day's work it should be enough. When I want to further process this data, a US cable is delivered with it. You connect it to a computer as well as the delivered software. It has to be installed. Then I can this data, all measured data or partially, transfer to my computer, and the delivered software makes statistic layouts and deviations and so forth. A nice small universal device with a high precision. A high professional measuring device to measure coating thickness from PCE, the CT 100. I have it here stood on my table. It is delivered first without any sensors because there are so many different sensors for so many different usages. They differentiate themselves depending on if you want to go around corners, angle sensors or anything else, as well as the resolution of the area you want to measure. And the sensor here, that is a FN 1.5, and it is simply at the bottom connected, and then I can freely go everywhere I want to measure. Like here on my probe gel, it is aluminium what I have here. Then I get it shown up there. When I go onto here, that is iron, also there. That means we see that I can move totally freely here with this measuring head. The device is thought for everywhere in the testing world, testing goods received in all areas where the quality of coating thickness from anything, if with iron or without iron pieces, it doesn't have to have something to do with iron. If it is lacquer layered on metal or metallic, covering or whatever, the usage is varied. It always depends on the user. So as with a car, you can drive all over the place but you can't expect the manufacturer to know where you want to go. You have your own ideas, just like such measuring devices. Let's have a look close at it. When I take it off its stand, I have here a very nice clear display. We have just seen that it switches over automatically, switches between iron and non-ions, and when I now delete here and go into the menu, you can see here that we have many choices. For one, calibrate option, if it should turn itself off, if the black lighting should be on, many different applications, contrast and so forth. What is interesting for me is that here the statistic, let us go into it, and now we can simply have a look at it. You can see straight away we can transfer the measured data to a computer, we can have a look at the computer moment, or we can call up a histogram. The skills of this device are, it can be measured data of this device on the display graphically present in different forms and possibilities. That means you don't have to run somewhere to an office to read the data. You can read it on site. How it looks like, how is the probe, how does the trend look like, what faults I have, and so forth. A very extensive amount of possibilities to evaluate the measured values. Here in the measuring mode, we can go into here too. Here we have also different possibility limits to set. I can always set to naught, that means I can standard add something to it or take something away. I can continually measure when I need it, and so forth. The automatic recognition, I had it turned on, you saw that at the beginning. I can also set it to certain materials, what I want to measure. A device with which you can measure coating thickness, depending on which sensor, from 0.1 micrometer up to 1.5 millimeter. There are many different sensors for it, probes really, in which you can go into all sorts of corners or holes or where else, and it switches the measuring process automatically around. It can in standard mode, first of all, direct measure, up to 10,000 measured values, save. Altogether it can save up to 100,000 measured values, and that is very huge. The measured values are transferred with the delivered USB cable and the software to the home computer, and there I can evaluate differently with the software or with a normal spreadsheet program. As we can see here at the moment, even here I can sort everything to special points on how I want to display it at the end to see what is happening in the production. If anything has changed or if any problems have occurred, or any errors have occurred, or whatever. That is a special application case. Delivered with it are also calibration foils. You can do a 1-point or 2-point calibration. It is naturally calibrated from work or by a high precision measuring device, the case always is. And I think it is a valuable aid to monitor the production of your own products. 2 devices from PCE. For one, the CT65, a very small handy device what every specialist for motor vehicles or for other things in the trouser pocket should always have with him. Which is very good value. It is high precision and simple to use as well. Here the data can also be transferred to a computer as well as by the large device. That is the CT100 from PCE. It has statistic evaluation, graphical presentation on the display. It is thought for the high professional operation, no matter if the bridge builder wants to examine his materials which are delivered, or if the rolling mill wants to see if the coating layer is okay, or whatever. The device has different sensors for the different tasks and does not let any wishes open. Both have a resolution from 0.1 micrometer to 0.1 millionth meter and are in the area where our eyes have long time stopped. I will do that exactly now as well. I will cease and hope you have a small stimulation for your occupation or maybe as well in a private area. So that was all for today. I wish you all the best and until the next time.